In this video, we will implement particle swarm optimization algorithm in Python. About particle swarm optimization algorithm, its working, mathematical models, and algorithm working with numerical example we already discussed in previous videos. For more details, you can check the link given below in the description box or in the comment section. Right now you can see here we have different steps used in this algorithm. First, define objective function. So for testing we are using here the benchmark test functions, as you can see here. After that we will initialize the position, velocity for each particle in the current population. Then using objective function evaluate the performance. So here you can see we have the local best. Local best means agent's personal fitness value, their personal best fitness value, their personal best position and the fitness value. Global best position and fitness value means best among all in the current population. So we will update their local best and global best. Then we will start the main loop for this algorithm. Here for each particle we will calculate new velocity and we will add this new velocity in their older position and update new position for each particle. After that, using objective function, again evaluate new position, their fitness value. Then again we will update agent's best position, fitness value, global best position and the fitness value. We will repeat this loop until the stopping condition is met, that is current iteration less than equal to maximum iteration. When this condition is met, stop and display the best position and the best fitness value that you found in the last iteration. Now step by step we will implement this algorithm. First we will import important libraries. First we have random. We are using this to generate the random number in this algorithm. Next we have numpy as np. Using this we can perform numerical operations and array manipulation. Then from kinter we will import message box. We will use this message box to display the final output, that is the best position and the best fitness value found so far. Now we will define a class for particles. So we have a class name we have particle. In this class we will define the particle. So here we will define the position, fitness value, personal best position. Here you can see we are using this initialization method to initialize position, velocity and agent's personal best position, personal best fitness value. Here we have self position. Now we define the personal position, that is position, their personal velocity, that is initially 0, like position. Next their personal best position, that is position. Then personal best fitness, that is positive infinity. So we already discussed in previous video, this is the positive infinity. It means during optimization process if we found better fitness value than initial, then we will consider the better one. So we define here their position, velocity, personal best position, fitness value. We will define the global best position and the fitness value. So we are using here the main function. So we are using here this main function to calculate the global best position and fitness value. So for this we have different input parameters like objective function, population size, dimension, maximum number of iteration. Next we have the swarm best position is none and we have swarm best fitness. Initially it is also positive infinity, and we have the particles list that is empty. So you can see here we initialize the position, velocity, and personal best position, fitness value, and then global best position that is initially none, and global best fitness value that is positive infinity, means we can update it if we found any better fitness value than the initial. Now we will initialize the position for the each particle. So here we will initialize the position for the particles randomly in the search space. So we will use here np dot random dot uniform. So randomly we will initialize the position. So upper bound, lower bound, we have for the first function 0.5, upper bound 0.5, and we have dimension. Next you can see here as we created the class for the particles, and it will store the position, best fitness value. We will update this class with the new agents. So here we have particle, that is particle position, and we will add new particles in the list. Here we have this particle. Done. So now next, how we can update the fitness values. Fitness value, will check if the fitness value is less than swarm best fitness. If this condition is true, then the swarm best position is the agent, is that agent fitness, and the is that agent fitness, and the swarm best position is the agent position. Then the particle dot best position is the agent position, and particle dot fitness is the agent fitness. Now we will start PSO main loop to calculate best solution. Here we will repeat this loop until the stopping condition is met. From in the range we have maximum iteration. We will do this for all particles in the list. We will do this for all particles in the list. We will update velocity. So for velocity calculation, you can see here this equation: new velocity is equal to weight inertia into older velocity, random number. This is any random number. We have coefficients C1, C2, agents personal best, then its position, then we have here global best and the agent position. We have here weight inertia 0.8, coefficient C1 that is 1.2, second coefficient that is also 1.2. You can change the parameters accordingly. Plus we have two random numbers, R1 that is random dot random. Next random number we have here, so we have two random numbers, R1, R2. Then we have this formula. Then you can see here this is the velocity formula we applied here. Now we will update Now we will calculate the new position for the particle, that is particle dot position. So here we will add the calculated velocity in the older position. So this is new position. And here we have the velocity calculation. Done. Now we will evaluate the fitness value for each particle. So here we have fitness, that is equal to, we will apply the objective function on the particle position. So on this position apply the objective function. Now we will update personal best fitness value. I will update the personal best. So here we will check if the agent fitness value is less than particle dot best fitness. Its condition is true, then particle best fitness is this new fitness, and the particle best position is the particle position. Now we will update global best. Now we will compare so here we will compare if the fitness is less than SOM best fitness. If this condition is true, SOM best fitness is the new fitness. We will consider this, so we will consider the new fitness value, and the SOM best position is the new particle position. Done. We updated here the personal best and the global best fitness value. Now now it will return the SOM best position and SOM best fitness value as the output, as we need the best position and the best fitness value among all as the output. Now we will initialize the algorithm parameters. Population size we have, suppose 10, and maximum iteration, suppose we have 100. Dimension, suppose we have 2, for example. Now we will define the objective function. So first objective function name we have f1. As you can see here, this objective function f1 takes position vector x as the input, and it returns the fitness value, that is np dot sum. Based on the objective function formula, it will return the value. Now we will create here the dictionary for the objective function. So we have here objective function. So we have here objective function, that is equal to, so we have just one objective function right now. We can add here more objective function. Test this with, so first we will test this for one objective function. Now we perform the iteration over the objective function using PSO function that we created here. So for function name we have the objective function. We will apply the objective function, that is in this objective function dictionary, and So here we will access the objective functions that are given in this objective function. Dictionary, right now we have only one, so we will add more. So we will add more after this testing. We have the output. We will display the running function name, that is this fun name, this function name, plus we will add here a new line. Next we will display the best position and best fitness. Here we will call the PSO function, and here we have different input parameters: objective function, population size, dimension, maximum number of iterations. So here we call this objective function to calculate the best position and the best fitness value. Output they will display is the output. We will display the best position found so far, plus in the string we have the best position value, and the new line, we are adding here the new line. Then we have the new output for the best fitness, that is the best fitness value we found is the best fitness. And we are adding here a new line. Then in the message box we will display the final output. Message box show info, here we have the PSO result that is stored in this variable output. So we will display this message to the user. So here we will add the fitness, that is equal to, we will apply the objective function on the position. Now you can see here the code is done. First we initialize the important libraries, then particles position, velocity, their personal best, global best, then initialize the position randomly in the search space. After that we updated the fitness values for the local and the global. Then here the main loop for PSO is started, and this loop is repeated until the stopping condition is met, until the maximum iteration. Then calculated the velocity, added the new velocity in the agent's older position, and then we have the new position for the agents. Then we applied the objective function, calculated the new fitness value, compared the new fitness value with the older fitness value, and updated personal best and the global best. Then we will return here the result, that is the best position and the best fitness value among all. So here we have the objective function that we applied here, population size, dimension, and then we will repeat this. Now run this code, and here you can see in the message box we have the running function, that is F1, here this one, and the best position we obtained here, this one, best fitness value 0.27074. Here we can change the dimension according to the objective function, 30, population size 100, iteration 1000. Then run the code, and you can see in the message box we obtained the best cost and the best fitness value. You can see here we have dimension 30, so for 30 dimension the best position and the best fitness value. Like that we can add here, so just keep it simple for testing. So like that we can add here more objective function to define next function, that is F2. It will return it will return np dot max. Here we will add the formula for the objective function, find out the absolute of x, and then we will call this objective function in the dictionary, that is f2. Run the code. Now you can see this is for the f1. Now you can see here this is for the first objective function, and here this is for the second objective function. So like that we can add number of objective function and check the result. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.